Okay, welcome to the third unit, Discrete Probability Distributions, and Learning Target 1, which is Simple Probability Distributions and Expected Value. This is not actually the simplest. What we're going to do in the next lesson is a little bit more simple than these. But by simple, we just mean that they don't really have like a pattern in that they just come from like the laws of probability, and you'll see that really quickly. So our warm-up, this is actually a lot more fun to do in class than it is to just watch online. But we actually had this wheel in class, and we got to spin the wheel. And the question is, what is the probability that you will get each section? What do you expect to win? Originally, I didn't give the angles, and so in class we asked like, what's the probability of each section? And so students were asked like, how would you figure out the probability of each section? And so and if you think about it, like, you guys can take the time to think about it, and I mean, we're going to do this together. But if you want to pause it and try this on your own, it's actually a really good exercise to go through. So the angles actually tell you like how much probability there is, and so assuming that point is right in the middle, and it doesn't look right in the middle, it's just because of the way that I took the picture, but they did a really good job at putting that right in the middle. And you've got like angles 110, 70, 35. It's obviously which ones are which. Like the $1 is 145, the $2 is 110. So there is likelihood to win $20, but you can see it's very unlikely. And so you got to think about how, like, what is the chance of winning $20? And so I actually got to like spin the wheel, and we found out that so we recorded how much each person got to spin twice, and the winner got a chocolate bar. And so we just made sure that afterwards we calculated the average that we won each time. So I think there were like 20 spins, and so we just calculated the average of each of those spins. And that's exactly what we're going to do today, is calculate the average. So when we say expected value right here, that's what we mean is to calculate the average. We did this in the first unit too. This was the law of large numbers, and what we expect to get all the time. Certainly we could win $20, but there's an amount we'd expect, and it might not be $5, it might not be $2, it might just be some kind of number in between those that we certainly can't get, but it is the average of what we're getting. So learning target is, I know the probability distribution is a function. That word actually came up from grade 11. There's a reason why we have to take grade 11 functions to take this course. And so this is probably going to be where we're starting to see functions. Describes the probability of different values for a random variable. This idea is probably going to be the maybe more challenging thing to wrap our heads around, but we'll discuss a random variable. I can represent the distribution as a table or a bar graph and use the table to calculate the expected value. So what we were seeing before with the wheel. A table and a bar graph, like this is actually the table of values that we remember from grade 9, the X and the Y. The reason why a table worked in grade 9 but it wasn't perfect is because it only gave you a sample of some of the points. Our table is going to give us all of the points. We could sample a line by saying some x values and the corresponding y values, but there's a whole bunch of points in between as well. So it was only a picture of what our function looked like. In discrete probability distributions, what this means is like there's a finite number and we can count them. So what is a probability distribution? This is a little bit confusing slide, but I just want to kind of get this out so that we can talk about it. The probabilities of all possible outcomes of an experiment or sample space. So if we've got like rolling a die, the probabilities of all possible outcomes. So the x values would be like 1, 2, 3, 4, 5, 6, and the probabilities would be like 1 out of 6, 1 out of 6, and so on. It is a function much like we saw in grade 11 where y or f of x is the probability and x is the outcome, what you want to find the probability of. So it is just like we had height in terms of time, we have probability in terms of the outcomes. I refer to all the inputs, the independent variable x, as a random variable. That when we say random variable, like we talk about the variable like the roll on a die. It changes. There's different amounts for it. We use the capital letter for all of those inputs, and the reason why we use that is because we're going to refer to the expected value, and expected value is only going to occur for all of the inputs. So we're going to use E of capital X, and then, but like we refer to individual values of X as X, the small letter, and you're going to see that come up in probability where we use P of X, just like up here we use F of X. That's a little bit confusing. Like you can kind of play that a couple times and certainly ask me if there's something you have trouble with, but I'd watch the rest of this and see what questions you have after. What's a discrete probability distribution? Discrete numbers are those that are counted and not measured. I'm not going to assess this in this unit. We're going to get back to this in the normal distribution when we talk about continuous. It's a much more interesting conversation with continuous. For now, like we're just really like talking about single specific input values, and they each have a probability that is found in the distribution. A probability distribution can be represented, as I said, as a table of values, as there are only a finite number of possibilities. Like we can't represent a line. We can as a table of values, but we still have to say it's a line. We still have to say it's a solid line because there's an infinite possibilities, even just between 2 points. Discrete probability doesn't have that. So it's a little bit more simple in that way, that we're just looking at specific values. Again, another kind of theory slide. The expected value, or the average of what we expect to happen. For a discrete probability distribution, there's a value that we expect to happen. So actually, if you're flipping a coin, you expect to get heads one time and tails one time, and so we expect heads to come up half the time. And so if we call like heads 0, tails 1, we expect to get 0.5. Maybe that's a little confusing. But it's calculated by the weighted average of the x values. This weighted average thing we're going to come back to, and we're going to tackle that on its own. But basically what we're doing is we're calculating the average. Much like we did in class, we spun the spinner a whole bunch of times, we calculated the average. That's exactly what we're going to do here, and I'll try to help you understand that. And that's going to be one of our mastery learning targets, is just the weighted average. Each x value comes up P of x percent of the time, so multiplying the probability by the x values and finding the sum gives us the average we expect. This little summation, this little sign here is called the summation sign. It's capital sigma. It's a Greek letter. It represents adding them all up. So let's see an example to help explain this. But basically what we're doing is for every outcome, so every input value that we have, like $2, $5, $20, we multiply by the probability and we add them all up. And so we can see that, like, we can see how much each of these come up. And this is actually like a formula for the average. And I'll keep explaining that. That's a little bit confusing right now, but like we're going to come back to this. We're going to keep doing this in every lesson. So this is just the first one. So the wheel distribution, the probability, you might have guessed it, like for $1, it's 145 out of 360 is 40%. For $2, the probability is 110 out of 360. For $5, the probability is 70 out of 360. And they have to add up to 360, but the last one is 35 out of 360. And we can see that these all add up to 100%. We want to keep them as like accurate as possible without rounding. I can check to make sure, like if I look at this, I'm going to get 6 on the end here and 14 on the end here, or 4 on the end here. So it is going to be 100.000. But I mean, if you get 99.999, it's not the end of the world. So we're just trying to be as accurate as possible. The probability distribution looks like this. So I mean, you can always represent these things as bar graphs. We just put probability on the left side here. Very simple. Google Docs actually does this pretty well, not very easily. It is a little bit tricky to get it to do it. And for the games fair, we'll outline how to actually do that in Google Docs. The wheel expectation. So we've got the probabilities here already set. You can see that they total up 100%. So what's going to happen is what I want you to imagine is, and my class rolled the wheel 20 times, and so I want you to imagine if we rolled the wheel 360 times, $1 would come up 145 times. That's what we'd expect. So what we do for the average is we take the $1 that's going to come up 145 times. We're basically averaging up 145 ones. That's what the average is. So 145 ones. So we're going to multiply the 1 by the 145. 110 twos, 75s, and then 35 20s. And so that's basically what this is doing when we multiply these two numbers together. And then dividing by 360, well, each term just gets divided by 360, although in an average, we divide by 360 at the end. So you can see we just multiply each one of these, and then in the end, when we add them up, we actually get the average, because you have to add them up. So each of these numbers has been divided by 360 already, but we could divide 1 times 145, 2 plus 2 times 110, plus 5 times 70, plus 20 times 35, divided by 360. That's going to be a big learning target. We want to make sure that you understand that this column here is calculating the average. So if you want to wrap your head around that, what I would do is I'd write out one. What we did on the board is we wrote out one, not 145 times, we wrote dot dot dot, 2 110 times, 5 70 times, 20 35 times. We multiplied, we divided everything by 360, and we got the same number, 393. That's what you're going to be asked to do in the mastery learning target. Just show that you really understand that by calculating it in both ways. You don't have to use an example like this. You could use a much simpler example. Something that's all at a 4. If these are all equally weighted and each probability was 1/4, it would be a lot easier to wrap your head around. So on average, you'll spin this wheel, you expect to win 393, and in fact, we actually got an average of 385, so we got very, very close in class. Very good wheel. Plinko, we've done this before. We've seen the same idea. This was actually another games fair project that students of mine did, and so they actually part of their game was they had to have a random number that would go between 1 and 9. And then depending on what you got, that's where you dropped it. But we're just going to, for the sake of Plinko, we're just going to do the probability that you drop it in the middle here. So if you drop it in the middle. And so these are all your outcomes, 0, 1, 2, and 4. Those will, some of them come up multiple times, but they only show up in the table of values once. Probabilities we're going to add kind of like the rule of sum. And then if you remember, the way we do Plinko is basically just the same way we do the Pascal's triangle. And so you can see that I took time to put these down here, so you can see how many opportunities there are for each section. So there's 8 ways to get here. I did the best I could here. If you hit here, if you actually drop through here, I assume that you're going to hit this peg and go this way, because how could you drop through there and go there? So I'm not sure if that's what they were initially intending, but so I just went through each number, had to start making the font smaller. We got each section, and so we've got a total number of possibilities here. If we add these up, this is the total number of ways to make it to the bottom. I think there's 4,000 of them. And so the number of ways to get 0 is 792 plus 792 out of 4,000, so about 40%. The number of ways to get 1 is 494 plus 494, so there's 2 ways here and here. Number of ways to get 2, there's 3 ways, 208, 924, and 208. And the number of ways to get 4 are just 44 and 44. Again, we get to play this as a class, and the winner got a chocolate bar. They dropped it twice, and I think somebody got in the 4 and the 2. So they did obviously really well. So the probability of getting 4 is only 2.2%. And so if you got those probabilities there, like just really these numbers on the end we really care about. If we do the average, we got 0 times 39.6, 1 times 24.7, and so on. If we add those up, what we'd expect to get is 1.005. I think we got 1.4, so we were a lot luckier than we expect. But 1.005 is what the average amount is. Back to the games fair, so we want to charge something like, if we're paying out $1 each time, we want to charge something like $1.50 or $2 for this game. So to play this game, you expect to win just over $1 each time. So you definitely will win $1. So you want to charge more than $1, or you're just gonna break even. Okay. So practice, we got some questions from the textbook. I wanted to talk about a 6-sided die. So what would be the probability distribution for rolling 2 6-sided dice and the expected value of each roll? And so certainly what I mean is the sum of 2. And so you can make a table of values with the probability that we did from the first unit. So we've got the number of ways to roll a 2, 3, 4, and then all the way to 12. And so there's no way to roll 1. Okay?